Welcome to The Explainer. Today, we're diving into something really cool. We're going to see how literally every single computer program in the world, from your favorite video game to your phone's calculator, is built using just 3 simple, Lego-like building blocks.
Here is our roadmap for today. We're going to cover 1. The 3 building blocks. 2. Making choices with selection. 3. Repeating steps with iteration. 4. Combining and nesting constructs. And finally, 5. Testing code with trace tables.
Section 1. The 3 building blocks.
Let's dive right in by thinking about programming exactly like snapping together Lego bricks. No matter how wildly complex a program might seem on the surface, it really just boils down to a combination of these 3 foundational constructs: sequence, selection, and iteration. Master these 3, and you are officially thinking like a programmer.
Let's start with our very first block, sequence. This one is super straightforward. It simply means doing things in a strict order, step by step. It's kind of like following a recipe, right? If a chatbot starts up, it says hello, and only then does it move to the next instruction. You literally can't skip ahead.
Section 2. Making choices with selection.
So, doing things in order is great and all, but what happens when our program needs to actually be smart and make a decision? That brings us to block number 2, selection. This is where the computer asks a question and goes down completely different paths depending on the answer. For example, if you are a student, it takes one path to show you school clubs. Else, meaning, you're not a student, it takes a totally different path to show you something else.
Section 3. Repeating steps with iteration. Our third building block is iteration, which is really just the fancy computer science term for doing something over and over again. Look at the repetitive code on the left. Imagine having to type out the same instruction 1,000 times. It's messy, and honestly, it's just super boring. But over on the right, iteration lets you write that instruction exactly once, and you just tell the computer exactly how many times to loop it. It makes your code way shorter, super clear, and saves you from a massive headache.
If we break down the logic in this flowchart, you'll see we use a counter variable to keep track of the loops. That little diamond shape, that's what checks the counter. As long as the answer is yes, the loop runs, prints hello, and adds 1 to our counter. It just spins round and round until it hits 5, and then, boom, it finally breaks out of the loop. You just have to make sure it actually has a way to stop, or else you're going to end up with a robot stuck saying hello forever in an infinite loop.
Section 4. Combining and nesting constructs.
Okay, so we have our 3 blocks, but the real magic happens when we start snapping them together. Because real code almost never uses just one block in isolation. We do this thing called nesting, which simply means placing one construct inside another. Notice how the selection if statement is sitting perfectly inside the iteration for loop here. Because it's indented, it means a brand new decision gets made every single time that loop repeats.
Section 5. Testing code with trace tables.
Once you snap all these loops and choices together, how do you actually prove your code works without your brain completely frying? Well, the golden rule is you should never try to hold a complex looping algorithm entirely in your head. It is way too easy to lose track and create a bug that crashes the whole thing. Instead, programmers use something called a trace table to predict the exact output. You just give 1 column to each variable and 1 row to every single pass of the loop.
Let's actually act like the computer for a second and fill this out step by step. We track our count from 1 to 5. The question is the count greater than 3? For rows 1, 2, and 3, the answer is clearly no, so it outputs small. But suddenly, right on loops 4 and 5, that condition is met, so it switches to big. By just methodically filling out the rows, the final outcome of small, 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 big, big just reveals itself perfectly. Absolutely no guessing required.
So there you have it: sequence, selection, and iteration. You now understand the 3 ultimate building blocks that literally power everything in the digital world. I have a challenge for you today. Open up your favorite app and try to spot where the developers used a strict sequence, a branch selection, or a repeating iteration. I guarantee they're everywhere once you start looking. Great job learning today, and keep exploring.